Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is maximum fruits harvested after at most k steps. The given input in the problem is a two-dimensional integer array, and let us call it as fruits. Every element in this fruits array is another array of two elements. The two elements are position and amount. This is your element in every 2D integer array. You are given two more integers as an input, and those are start position and k. The output we need to give in the problem is the maximum harvested fruit amount. Now, if you focus on the input, we are given a 2D integer array, right? And that integer array is having another array, and that is fruits array, in which every element is the position where the fruit is kept and the amount of fruit or the amount you can gain if you are able to harvest this particular data. Now, let us try to understand more about this particular problem using an example. In the given example, this is our 2D fruits array, in which we have total 3 data, and every data is another list or integer array. The first element is the position, the second element is the amount. Then we have the position and amount. We are also given a start position, which is 5, and the value of k is 4. Now first let me tell you what are these fruits array all about. So we have an infinite x-axis, and the fruits array given are sorted via the positions. So the positions will always be in sorted order in the input. Now what we need to do is we need to put these fruits, or we can say these particular data, on the x-axis. So at position number 2, we can put this particular data, which can give me a total amount of 8 if we are able to harvest this particular data. So at position 2, we can gain a total amount of 8. At position 6, we can gain a total amount of 3. And at position 8, we can gain a total amount of 6. So the array is given in sorted order via positions. So positions 2, 6 and 8 are sorted. We are also given a start position 5. It means we are standing at the point 5, and the value of k is equal to 4. It means we can take a total of 4 steps. We can take total of k number of steps, and we need to find what's the maximum amount of fruits we can harvest. And when we say harvest, it means that if we are able to come at this point, it means we will be able to get a total of 8 amount. A total 8 amount of fruits we can harvest. So we just need to find out the maximum value which we can harvest. And when we say k is equal to 4, it means we can take a maximum of k steps or 4 steps. So if our starting position is 5, and if we want to harvest this particular data or this particular fruit, then we need to travel a total of 3 distance. From 5 to 2, we need to travel in the left direction, and the distance will be 3, right? How can we find the distance? Simply 5 minus 2, right? So we need to take some steps to go to a particular fruit or a particular data and harvest it to get these amount. The amounts are given at index 1 of the array, and the positions are given at index 0 of the array. Now we can move in the left direction and right direction both. But the thing is, we cannot move more than k times, or we cannot take more than k steps. So for this particular data, the output is going to be 9, and let me tell you how. If our starting position is at 5, and let us say we want to harvest this particular data, so we need to move in the left direction, right? I will move a total of 3 steps, and I will be able to harvest this particular data. So right now I have moved 3 steps, and I have got a total of 8 amount. But now I am left with just 1 step, right? I was allowed 4 steps, I took 3. I can only take 1 more step. And right now I am at this point. If I go to the left, I don't have any fruit to harvest. If I can go to right, I don't have any fruit to harvest. I can go just 1 step, right? So if I go from my starting position to this particular fruit to harvest, the total I can gain is 8. But instead of that, what I can do is I can go in the right side just 1 step, and I can harvest a total of 3. Then I can go 2 more steps, and I can harvest a total of 6. So the total harvested amount is now 3 plus 6, which is 9, and I have taken just 3 steps as of now, right? I have moved from 5 to 8, and in between I was able to harvest these 2 data. So 3 steps and total 9 amount. I still have 1 more step left, and I am at this particular position. If I go right or if I go left, I don't have any more fruits left to harvest. So the total amount I can harvest maximum is 9. That is the output for this particular data. This is how we need to understand the problem and solve it. Now let me try to explain you the solution approach with another example. First, let me solve this particular example as well. And once I solve this, I will go one step at a time to explain you what's the process, what's the intuition behind solving this using programming code. In this particular example, we have these many data. That's our 2D fruits array. We have a total of 1, 2, 3, 4, 5, 6 data. The positions are sorted, right? It is 0, 4, 5, 6, 7, 10. So I have put these fruits on their positions, which are 0, 4, 5, 6, 7, 10. And the amount we can gain is 9, then 1, then 7, then 2, then 4, then 9. Now our starting position is 5. We are at this particular point, and the number of steps we can take is 4. That's the maximum number of steps we can take. Now for this particular data, the output will be 14. As of now, we know the output, but when we will approach to solve this particular problem to understand the intuition, we will assume that we do not know the output. But for now, the real output for this is 14, and how we can find this? If we are at this particular position, that's our starting point, we don't need to move and we will still have 7 amount because we are at this position. At this position, we have a fruit to harvest and we can gain a total of 7. So now we have a 7 amount with us without moving, but now we can move in the left hand side just one step. So if these are the 4 steps and I take just one step, I will be at this particular position and I will have one more amount. So 7 plus 1. Now I can go to right again. I will be at 5, the position number 5 again. But now I don't have any more fruits to harvest because I have already harvested 1 and 7. Now I can go to right again. Since I am moving 2 times, let me cut these 2 points. I have moved a total of 3 steps, and the moment I reach to this particular point, I can harvest this particular fruit as well, and I will gain plus 2. I still have one more step to take. I can take that step in the right side and I will gain total of 4 more amount the moment I reach this point. So plus 4. 4 plus 2 plus 1 is 7. 7 plus 7 is 14. That's the output we have. From here I can understand that we don't need to move in a certain direction every time. We might need to move in both the directions based on the number of steps which are allowed to us and the position at which we are and the positions at which the fruits are kept. So we cannot just move in the right side completely or in the left side completely. We might need to go in the left side, then come back to cover the right side. That's what we have done in this particular example to have the maximum of 14 amount of fruits harvested. From here I can say that I can actually harvest a particular set of window. That is, I have a window which I can harvest based on my starting point and based on the number of steps I can take. As of now, I was allowed just 4 steps, but instead of 4, if I would have been allowed 7 number of steps, then I could have covered this particular point as well. If I have 3 more steps, let us say I have 7 steps, right? So I am at this particular position, I can go to left, I will have 6 more steps left. Then I can go in right, one more right, I will cover this one. I already covered these 2 points. Then one more right, I will cover this particular point. And I am at this particular position. I have taken a total of 4 steps. Now I can take 1, 2 and 3 more steps and I can cover this particular point as well, and I can gain 9 more points. So my total will be 23, 14 plus 9 which will be 23 when the number of steps allowed are not 4 but 7. So from here I can say that instead of covering this particular window, because I had just 4 steps allowed, I could have covered this particular window of data if I was allowed a total of 7 steps. But we need to do it smartly, right? If I am at this particular position and we are allowed 7 steps, and if I take the step in the right side first, if I go right, I have covered these 2 points. If I go one more right and I have covered this point, if I keep going in the right side, I have taken a total of 1, 2, 3, 4, 5 steps and I have covered these 4 points. I still need to cover this particular data, but since I have already taken 5 steps and I am at this particular point, to go to this particular point, I will have to take a total of 6 steps, which will be 5 plus 6 equal to 11 steps, right? If I want to go from position number 10 to position number 4, I have to cover 6 steps. So it is very important to understand that we cannot just go to the right side or the left side first. We need to find which direction we can go, and what we can actually do is we can try both the directions. We will see that if we go to the right side first and then left side, what will be the gain, or if we go to the left side first and then right side, what will be the gain. But when we go in the left side or in the right side, we will always keep a window which we are targeting. And the reason is we will always get a window as an answer, right? If k is 4, this was our window which we were able to cover. If k is 7, then this was the window we were able to cover. So what we understand from here is, let's try for all the windows, right? And for all the windows we have, let's try to do 2 things. We will see that can we go to left side first to cover the entire left side of the window and then the right side, or should we go to the right side first to cover the rightmost point and then come back to the leftmost point. That is, if I am at this position and this is my window, and if I say that I want to go left first, if it means I want to cover the entire left point of my window first and then I will go back to the entire right point. This will take a total of 4 steps. But what if this is my window and I want to go to the right side first and then the left side. So if I'm at this particular position and if I cover the right side first and then I come back to the left side to cover the left point as well in my window, I will have to take a total of 1, 2, 3, 4, 5, total of 5 steps. I am only allowed a total of 4 steps. But we can do both the things, right? We can go to left first and then right, or right first then left. So whatever is the minimum steps that we will take. Now let me tell you how we can solve this. Now since we know that we need to cover a particular window, right? So this gives me an idea that I can use the sliding window technique. Now you will have to understand that the intuition which I have built to use this particular algorithm has come after I was trying to solve this particular problem manually. I didn't know about window, I didn't knew about sliding window, but now I know that sliding window technique can be used, and the reason is you will have to catch the intuitions at each point. The moment I see we have a window and our data is in sorted order, right? The positions are sorted, they are not randomly distributed. It means I have a window which can be fixed at a particular point, and then I can slide my window to either increase the window size to cover more points or decrease the window size if we are not able to cover my current window size. So all these things are indicating that the pattern sliding window technique can be used. Now we need to cover all the windows and we need to check if we go to left first or right first, whatever give us a valid output, that can be an answer. For example, if I don't know about the output, that the output is 14 and my starting position is 5, right? So what we can do is we can say, okay, let me try all the windows. So at one point, I will try this window as well, right? The window of 1,7. This particular window will give me a total of amount 8. Can I cover this particular window? That's what we need to see. If I am at this position, I have to move left 1 point and I don't need to move right. And the reason is we already have covered this particular point since our starting position was 5. And by moving 1 point left, I have covered this particular point. So the thing is, I am able to cover this window within the limited number of steps we have. We just need to move one step and we can cover this particular window. Now, since we can cover this particular window, which can give me a total of 8 amount, the next thing is I can try to extend my window size. Instead of trying with 1,7, let's try to increase the window size to 1,7,2, this particular data. Can I cover this window? So now our window is 1,7,2. Alright. As of now, I have not told you how to build that window, but let us say we are able to build the window. So if this is our window, can we cover this? Let's try this. We have to try two things, left first and right first. Alright. Let's try to go to left first. If I am at this point, I go left first and then I go to the right points to cover the entire window. I have to travel a total of 3 distance or 3 steps. 1 step in the left and then 2 step in the right. This will cover the entire window, and the entire window is giving me a total of 1 plus 7 plus 2, that is 10 amount, which is actually better than this particular window. Now since we have a better window, we can discard the previous window of 1,7. Now my current answer can be 1,7,2. And this was if we were trying with left first. Let's try with right first as well, because we don't know pre-hand that left first will be the better answer or right first. So let's try with right first as well. Now if we go to right first to cover the right point of our window, and now if I try to cover left point, I will again have to travel a total of 3 distance. 1 in the right, then 2 in the left. So traveling right and traveling left both are taking 3 number of steps, and we are able to cover this window. So we can say that yes, this is a valid window. So this should be our approach to solve this particular problem. And now let me take this approach to solve this particular problem quickly. First of all, what we will do is we will start from the starting position. See, when we have a window, then we have a left point and a right point. If this is our window 1724, then the left is 4, the right is 7. This is the classical sliding window technique. So we can start with at the starting position, and let us say this is our left and this is our right. This is my window. As of now, I am saying that can I cover this window? So first of all, you will have to understand that it is not important that you will be able to cover the entire window or all the windows you have. If this is my first window, let us say, then my left is at 0, my right is at 0, right? But my starting position is 5. I will have to travel a minimum distance of 5 to reach to this window, right? To cover this window. But I can take just 4 steps. So it is not possible, right? This is a not possible window. So this is wrong. So we will ignore this window and we will move 1 point ahead. Now this is our window, which doesn't have any fruit. Even though you will be able to cover the window, the total amount will be 0. So what you will do is you will say, okay, let me try to increase the size of the window. Let me try to again increase the size of the window till the point you are able to cover. At a point you will reach here and you will say that this is my window. Now if this is your window, your left is at 4, your right is at 4, right? That's your position. You are at this particular position, and let's try with this particular window. Can you solve this particular window? Alright, if you want to solve this particular window, you can move one direction in the left and you are allowed 4 steps. But just moving one in the left, you are able to solve this window, right? Or you are able to cover this window. So this is a valid window. Now the moment it is valid, you will be increasing the window size. This will also be valid. Then again you will increase the window size. This will also be valid. Then again you will increase the window size. This will also be valid. Now let me show you how this is a valid window. What will be our approach? Let us say this is our window, right? So your left point is at 4, your right is at 7. Alright. Now we need to do two approach. We have two approach. We can either cover the right side first, RF, that is right first, then left, which will be the starting position is here. So first cover the right points first. This is my extreme point of the right side of the window. So I can say this is the distance I will have to cover. And now to cover this part of the window, I will have to travel back, right? So I have to cover 1, 2, 3, 4, 5, total of 5 distance if I am trying with the right side first. This will be my total distance which I will need to travel. So you might say that, okay, this window is not fine if I travel to right first. But what if I travel to left first? So I will have to go to the left. That will be a total of 1. And then I will come back to cover the entire right. Will be 1, 2, 3. So a total of 4, right? So if you go to left first to cover this window, you will have to travel 4 steps. If you want to cover this window with right first, then you will have to travel 5 distance. Obviously, you can choose the minimum one and you can say that this is a valid window because I can go left first, right? Now, how to calculate these values? It is very important to understand. Let me tell you how. If you are at this particular position and if I go to left first, then what is happening? I am going to the left side first, right? Which is actually the starting position minus the left position. This is my left position, right? The left position of my window. So I have to cover a total of one distance first, and that will be the start position minus the left position. And then to cover the entire right side, what I will have to do is I will have to say the right point minus the left point, because right now I am at this particular position. I'll have to go to the entire right position, so it will be right minus left. So the formula to calculate left first will be start position minus left position plus right position minus left position. This will be our formula. And similarly, if you want to travel right first, it will be, you are at this point, you will have to cover the entire right point. So it will be right minus the start position. So we can say right minus start position plus, now you have to go from right to the left. So it will be right minus left. So plus right minus left. Now whatever is the minimum, if it is within the limit of your steps, you can say that this is a valid window. If this is a valid window, you will again later on try to increase the size of your window. But now if you increase the size of your window, you are going to take at least 5 steps. At least 5 steps when you go left first, and at least 6 steps when you go right first. So now you cannot increase the size of the window. So now you will have to move your left pointer, and you will have to say my left is here, my right is at this point. Can we cover this? That will be our complete approach. Just keep increasing the window size and keep checking, can you cover this window? If you can cover this window, what's the maximum you are able to gain? Now let me take you back to the code editor and let me show you how can you solve this particular problem using Python. So first of all, we will have n is equal to length of the fruits, that is total number of data we have, then the maximum fruits we can harvest, and the total fruits we can harvest in each window. This is our left pointer, which is 0 for now, and then we run a loop in our range of n, which is our right pointers. First of all, we will say that our current window has a total of total plus fruits of right, and then at index 1. So basically the new data which we are having at each point in our loop, we will cover that data and we will take its amount. The amount is at index number 1, right? Position is at index number 0. Now we will check for this window that can we cover this window or not. Right now we are saying that the total harvested amount for this window is total, but can we even achieve this window? We can check here. And this is the classical sliding window technique. While the left is less than equal to 0, let's find the left position of our window, and then let's find the right position of our window. And let us say if we go left first, so the formula will be start position minus left position, and since the value can be negative, I can say absolute value of this plus right position minus left position. This will be the total number of steps I need to take if I travel left first. What if I travel right first? Then I will have to take absolute value of start position minus right position plus the right position minus left position. Now once we have calculated the left first steps and the right first steps, we will consider the minimum value of this, and we will say if this value is less than equal to k, we can break. It means we have found our window, that this window can be achievable. But if this window is not achievable, what we will say is let me slide my window from the left side, and then what I can say is total will be equal to total minus fruits of left and then 1. It means because I have shifted my window from left to left plus 1. So left is equal to left plus 1. And then when we are out of this particular loop, we can say that at every point, maximum fruits we can harvest will be the maximum of max f, that is whatever was my last window and whatever is my new window, which I am able to cover. So every window will be calculated in total, and the maximum amount will be calculated in max f. Whatever will be the maximum will be assigned to max f, and when we are out of the for loop, we can say return the max f. This is going to be the complete solution for this particular problem. You can submit this and this will pass all the test cases, and this is a very efficient solution. You can see the runtime is very good, the memory used is very good. So we have solved this particular problem in a very efficient manner. Now, if you are able to understand the problem and the solution approach, and more importantly, if this video explains you the intuition behind the solution, the intuition behind sliding window, then make sure that you are hitting that like button. And if you have not subscribed to the channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.